So I was discussing about total number of a possible trees, right? So what could be the total number of a possible trees? What is the formula for total number of a possible trees? See, in a graph theory, the questions will be very less. Means like they are asking you questions like after 4 5 years 6 years. So it's included in the examination, but it's not that much important. Okay, but you should not leave any topic. Okay, in case the examinations they will ask, and they are asking a very simple questions: what is the total number of links, what is the total number of trees, what is co-trees, what is twigs. They are asking questions very simple like that only. So what is the possible total number of a possible trees? Write it down. Total number of a possible trees, the formula for total number of possible trees is n into n minus 2, n into n minus 2. Okay, and you know the number of means in these questions what was the total number of nodes? 4. 4 minus 2, so how many trees you will get? 4 to square, 16 trees you will get, right? 16 trees you will get. And I will give you one example which is not your tree. So this is not your tree because it's forming a closed loop. This can also be another blunder what people used to do. This is not your tree. Okay, and this is a total number of a possible, but for getting the accurate results, if you want to get the accurate result, there is a proper formula for finding the total number of possible trees for any graph. See, actually what the formula I gave you now, this formula, it's not applicable to everywhere. It's applicable for, write it down here, the above formula is applicable when all the nodes connected together at least once and only once. Okay, like I'm giving you this particular, this is your graph. So this is A node, this is B node, this is C node, this is D node. So this node is connected to B, means only once time. Okay, only once time from A to B, from B to D, only once time from A to D, and from C to D, and from A to C. So there is a connections between the pair of any nodes only once time, and all nodes should be connected at least once and only once. And if you have a graph like this, suppose if you are getting a graph like this, this is A, this is B, this is C. So A to C is fine, B to D is also fine, and C to D is also fine. But if you are getting a something graph like this, so there is a two connections coming, A to D also, A to D. So in this kind of a situation, you cannot use this formula. Okay, and if you want to get the proper formula, means for any graph it is applicable, the total number of possible trees for any graph total number of, so it will be determinant of what? Determinants of reduced incidence matrix and its transpose. So what was the, it is your reduced incidence matrix and its transpose. So what is the transpose? X, Y, Z, L. If you want, this is your A matrix, and if you want to make it as a transpose, so how it will come? This particular will shift this side, and this particular, this will come this side, and this will come this side. So this is A transpose. Okay, the row will come down, the row will come down like this, means the row will become column. So first row is becoming your column, second row is becoming your column. So what you have to do, you have to put the incident matrix, okay, and take the transpose of that matrix, multiply that, and find the determinant. You will get the possible number of trees of any graph. Okay, so this was the concept of this. Write one formula, the total number of node pair voltage. So this is also one important formula. Write it down. The total number of node pair voltage. So it's very simple. NC2, that is n into n minus 1 upon 2. Factorial 2 is factorial 2. So total number of node pair voltage will be n into n minus 1 by 2, NC2. Okay, and total number of edge or vertices in complete graph. So this was one important formula, and if in examinations they are asking the total number of edges. So I hope you know the meaning of edges and vertices. Edges or vertices in a complete graph. So it is NC2, same formula only, n into n minus 1 by 2. So this both formula are same. If in examination they are asking total number of node pair voltage, and also they are asking total number of edges or vertices in a complete graph, so NC2 only. Okay, okay guys, and there is one concept of tie set matrix. Like if I am giving you one question, so first write the question, then I will tell you the procedure. First write the question. Question says develop the tie set matrix. Develop the tie set matrix for the below given electrical network. So the network is like this. Okay, and you need to develop the tie set matrix. This is your capacitor, and from this it's negative, it's positive voltage. Okay, and this is to this. I am directly taking, so I am supposing this is my branch 1, this is my branch 2, and this is my branch 3, this is my branch 4, again I'm taking, this is my branch 5, and this is my branch 6, branch 7, and this is my branch 8. So total number of branches we are getting 8. So write down the procedure how you will develop the tie set matrix. Procedure for developing the tie set matrix. Okay, so first step is develop a graph for the given network. So you need to first develop the graph. Second step is identify a tree. Identify a tree and links also from the graph. Then identify the total number of basic loops or a fundamental loop. So what is this? I will tell you. Identify the total number of basic loop and fundamental loop. Okay, basic loops you can say, or fundamental loops. So right here, or basic loops or fundamental loops. Okay, so what is fundamental loops? Or we can say it as an impedance loop also, or means a lots of name is there. F loop or impedance loop, lots of name is there. So basic loop consists of only one link. What is the meaning of a basic loop? In basic loop consist of only one link. Second, basic loop direction is same as the link directions, link current directions. Basic loop direction is same as the link current direction. Okay, so total number of a basic loop is equals to total number of basics loops is equal to the total number of links only. Total number of links. And links formula I told you, b minus n minus 1. Total number of links. Okay. So links is actually the code tree, that dotted line. Okay. So in your basics loops you will get one link. Okay, means for forming one loop. So total number of basic loop is equals to the total number of links. And the formula for links is b minus n minus. Okay, so now let's solve the questions. That question. So for means you had make the circuit was, let me take that circuit again. So this was my circuit. This particular was my circuit. So from this we need to first develop one graph. So if I want to develop the graph, my graph will be like this pointed part and this part. Draw whatever the notations, same notations, 4 5 1 6 7, this was 8, this was 3, this was 2. Now the second step is to draw one tree. My second step 2. So this was my step 1. and for step 2 I need to draw one tree. Tree means what? Your all node is connected. So this is my node, this all are my node. So if I am taking a tree, so tree could be like this, like this. So all the 4 nodes are connected. And what is your, this is your tree branches. What is your links or code tree? Dotted line, dotted line. This particular is your links. Okay, this particular is your links. So you had assumed the current, that 4th branch current like this, your I1 current from this is your 5th branch, and you are assuming the 3rd, okay, and this is your 2nd branch. So anything is there, that is your 7th branch. So these things are present only. Okay, so this is links. Okay, so how many basics loops you are getting? I told you in a basics loops you need to get one links. So I am forming one loop like this. This is my I4, giving the name as I4. This is 8. Whatever the links you have to choose like that only. And I am assuming like this, this is my I1. I am assuming like this, this is my I2. I am assuming like this, this is my I3. What was the statement? Just see the statement. Your basics loops consist of only one links. Only one links. Basics loop direction is same as the link current, and total number of basic loops will be equal to total number of links. So guys, in this particular, how many links are there? 1, 2, 3, 4. So how many basics loops will be there? 1, 2, 3, 4. And the directions of the basics loop will always be same with the directions of links. So now you need to develop your set matrix. So write it down. Your set matrix is denoted by B. And how many currents you are getting? 4 currents. So I1, I2, I3, and this is my I4. Yeah. So okay guys, now you need to create the set matrix. So how you will develop the set matrix? So it's very easy, it's not that much tough. So you have to write all the branches from 1 to 8. You have to write all the branches. First branch, second branch, third branch, fourth branch, fifth branch, sixth branch, seventh branch, eighth branch. Okay, now you have to develop, okay, the set matrix. Okay, so how you will make the set matrix? From see, in I1 current is this is your I1 current. So if I1 current is this, so how it is following the I5? This is your fifth branch, it's opposing, so fifth will be -1, and this was your sixth. Okay, how it's following the sixth one? It's opposing, so sixth will also be -1, and there is a no seventh and 8, and it's a I1 loop, so we'll get 1 only for 1. Okay, for I2 will be 1, for I3 will be 1, for I4 will be 1, and you have to do the same things for I2. See your I2 is this one. So how it's following I2? It's opposing the sixth one. So if it is opposing the sixth one, so I will give -1. And what about seventh? It's supporting. So the current directions I had assumed like this, and it's supporting this in this direction, so it will be plus 1. So like that you have to fill. And what about I3? I3, the third part will always be 1 because the links it's supporting only. And the seventh, it is supporting. Seventh, it is supporting. And any other branch, 8, it is opposing or supporting. It's going like this supporting only. So 8 will be 1. What about, yeah, so we had fail. Yeah, third. So third left. So I3, oh, okay. Third left. So third was this. So, and this was fourth one. So see the fourth one. I4 will be 1 only, and I5. What about I5? It is supporting or it's opposing? See the direction. It's opposing. I5, it is opposing. So it will be -1. And another I8, it is supporting. So guys, this part is known as up to fourth, it is known as U. And this particular, what the extra terms means, I1, I2, I3, I4 up to 4 is the series you are getting like this. So up to this it is known as U, and from here it will be known as a BT. So B matrix is nothing but your B, capital B matrix is nothing but augmented matrix of okay. So from this we will get the KVL equations. So we can use KVL from Tysett matrix. We use KVL. So what is the U matrix? U matrix is this one, and wherever the nothing is present, so it's 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. So you are getting a two sets of matrix, U matrix and BT matrix. Okay, so Tysett matrix represented by like this. So here you will getting one matrix, and your BT matrix you are getting one matrix. I think you understood this concept, means how to find the Tysett matrix. Prasanna, have you understood how we are getting the Tysett matrix, or any confusion? Yeah. BT is just nothing but it's a representations. See, how many loops we got? I1, I2, I3, I4 na? I1 loop, see the loops. I1, I2, I1 loop is there. You get the I2 loop, you get the I3 loop, you get the I4 loop. So always you will get the sequence like this: I1, I2, I3, I4, diagonal matrix. And after that, whatever the terms, its remaining terms, so this particular matrix is your BT matrix. So if anyone will ask you what is the BT matrix, so this particular matrix is your BT matrix from 5, 6, 7, 8. So BT matrix is this one only: -1, 0, 0, -1, -1, -1, 0, 0, 0, 1, 1, 0, 0, 0, 1, 1. This is your BT matrix. So just a representations. And your U matrix, so U matrix means what the links you got it, what the loops you had assumed. So you will get a diagonal loops like this. Okay, try to get it may not be in a diagonal, but just try to represent like this in a diagonal, so it will be fine. So you will not get this kind of a question in examination, so not to worry. I'm just saying the procedure because I have to teach everything. So remember one thing, the basic point is that we use the Tysett matrix for finding the KVL. Okay, we use the Tysett matrix for finding the KVL, and Tysett matrix represented by B, that is nothing but U is to BT, U augmented matrix with BT. Okay, You augmented matrix with BT. So if anyone is asking you, Tyset matrix represent all the things here. Okay, so up to this part it will be U, and this part is BT. So you directly represent all the things like this. This will be your Tyset matrix. But from where to where you are getting the diagonal elements, it will be your U. And from where you are not getting the diagonal matrices, it will be your BT. So you can directly represent the whole matrix like this. Okay, is this clear? So the last topic is for a graph theory is cut set matrix. So we'll see the cut set matrix. So you need to develop the cut set matrix for the network given below. So this is your network, this particular is your network. This is your network. Okay, this is your negative positive. So now you the same network, it's 4, 5th branch, 1st branch, 6th branch, 8th branch, 3rd branch, that was 7th, and that was 2nd. So from the same network you need to create. You understood the Tyset matrix. Now you have to do for the cut set matrix. For a Tyset matrix, we use the Tyset matrix for finding the KVL. We will get the KVL, and and if you want to find the cut set matrix, it is used for KCL. So we'll see it tomorrow. So then after that the graph theory will be over. In a graph theory, the thing is that what the formula you got now, what the things you have to remember, a procedure of this, it's not require a depth knowledge of the graph theory. What is the total number of basic loops, the formula, same, it means they are asking us very simple questions. They will give you the branch, they will give you n, what is the total number of basic loops, what is the total number of finding the trees in any graph. So that what I told you, reduced incident matrix into the transpose of the reduced incident matrix, determinant of that. And one thing's what I told you, total number of edges or of vertices is nc2, that is n into n minus 1 by 2. Total number of a pair voltage is n into n minus 1 by 2. Okay, and I will give you one example of this. And this is augmented incident matrix, how to find, I told you. And this is your reduced incident augmented matrix. I taught you about the trees. What is trees? Okay, the concept of trees. So this is your trees. And what is trees? What is co-trees? What will be the total number of trees? The total number of tree branches, that is n minus 1. And total number of co-tree branches, b minus n plus 1, or you can say b minus n minus 1. Okay, total number of a possible trees, n into n minus 2. But this things is possible in this kind of a situation, not in this kind of a situation, because it's getting touched to node D twice. Okay, and for any circuit, if you want to find the total number of trees, you have to use this formula, determinant of reduced incident matrix into reduced incident matrix transpose. And I taught you how to find the Tyset matrix, the procedure of this Tyset matrix. So you need to first find the graph, then you have to draw one tree, then co-tree means like a links, then you have to make the current directions with respect to the links only, and write like this the links, you have to write like this. Then you are getting a diagonal elements, means you cannot write, if you will write I1 first, then if you will write I3 first, you will not get the diagonal. So it's up to you how you are representing your this you this basically you means in which in which row you are getting links. So in row 1 we are getting, in I1 branches we are getting the links, in I2 branches we are getting the links, in I3 in this row where we are getting the links, in third, in I4 where we are getting the links, thus fourth. So we had is assume like this, and this is what it's supporting, or it's opposing. Okay, the rest of all is known as BT, and whole this is known as your Tysett matrix, and this Tysett matrix is used for KVL. Guys, understood? Prasanna, understood? Prasanna, understood? Priyanka, understood? I'm asking with you guys. So don't get nervous, means like uh, if you are means like it's not a very much important chapter. I give you the whole knowledge. You have to remember that formulas only, and if you will solve the previous year questions now, you will easily get to know what this meaning of things. So tomorrow we'll start the next chapter, that is filter filter and magnetic circuit. And tomorrow only your network theory will be completed. From tomorrow the network theory will get complete. Okay, and after that we'll start the new subject, and in between this we will make one day for question solving. All the way, means like if you'll see that I am solving a very much important questions in a class only. So from with the reference of that also you can use that questions, and you can solve previous year questions. If you will try, you will easily solve all the questions, and whatever the problems you are getting, you can ask me. Okay. Okay, guys. Signal system. You want any other subject, or it's fine for signal system? Signal system, it's very interesting. You will enjoy it. It's like a maths. Okay, signal systems. Network was also like a maths only. Signal system, in that you will understand the basic flow of a signals. Like most of the guys are hating the subject known as a DSP. Okay, digital signal processing. So if you will understand the signal process now, signal system, you are going to enjoy the DSP, digital signal processing. Okay, and that we'll study what is causal system, what is anti-causal system, what is ramp signal, what is unit step signal, Laplace transform, Fourier transform, Z transform. Okay, and how we can make any graph in the form of a sinusoidal, what is fundamental frequency, what is harmonics. So these things I will teach you in a signal system. And if you guys will say, then I can start the control system. So if you are okay with the signal system, it's fine, or any other subject you want. Signal system only, no? So why I'm teaching the signal system and network first, because this network and signal system is going to be used in a control system also. Okay, and if your network is strong, if your signal is strong, if your control is strong, then power electronics is the combinations of analog electronics, signal system, and network theory. So for going to a power electronics, first your network theory should be strong, signal system should be your strong, your analog should be strong. Then we'll move for power electronics. Okay, same case for electrical machines. If you want to command the electrical machines, so again network criteria is very much important. Some basics knowledge of EMFT, electromagnetic field theory. Okay, and yeah, means like that what we are doing, it's okay, but after some days we have to take a class like 4 to 5 hours. daily 4 to 5 hours, because we need to complete the syllabus. For one subject only it's taking a lots of time. So we will if possible, if I'll get the time, so I will increase the amounts of time. Okay. Okay guys, we'll meet tomorrow. Thank you. Oh my goodness.